on with what we just finished doing. We just have, there's like 2 new pieces of information that we add on to what we did in the last unit. So the value of trig ratio for an angle theta is related to the value of the same trigonometric ratio for the supplement of the angle 180 degrees minus theta. Okay, so what does that mean to us? Well, what's the easiest way to explain this? If I have an angle theta here, and I take the ratio of this angle, theta, okay? Let's say this angle is 30 degrees. It's going to give me a ratio of 1/2, okay? The sine of 30 degrees is equal to 1/2. Well, if the sine of 30 is 1/2, that means that my ratio is 1/2. Now, is there a correlation or with the sine of the supplement of that angle? And the answer is yes. Okay? If I look at this angle now, that angle right there, that measures 150 degrees. What we find out is that if I take the sine of 30 degrees, I'll get the ratio of 1/2. And if I take the sine of 150 degrees, I'm going to end up with the same solution. So punch that into your calculator then. Take the sine of 30, make sure you get 1/2, and take the sine of 150 and see what you get. Also 0.5, right? Okay. So what happens if I have a sine ratio like this? Sine theta is equal to 0.28. Okay? So for what angle will I get a ratio of 0.28? Go ahead. What is it? 16.260 degrees. So that's the positive in what we would call the reference angle, okay? But we don't need to worry about that just yet. We're going to get to that a little bit later on. But what is the other angle between 0 and 180 that is also going to give me the sine of 0.28? Okay, so I'm going to get, when I take my calculator and I go second function sine, it's going to give me an angle between 0 and 90 at all times. Okay, as long as the angle is positive, or the ratio is positive. So what is the other angle? How do I get the other angle? I take 180 degrees and I subtract that, and it will give me the exact same ratio as 0.28.
163 on 163. 163.
Oh, sorry. 163.739 degrees. That angle, if I take the sine of it, will give me a ratio of 0.28 as well. Okay? Everyone's all right with that so far?
How did you figure that out?
Because if the angles are supplementary to each other, you'll end up with the exact same ratio
Okay.
for sine.
Okay.
Okay? It works every time for sine. So when you use your calculator and you use second function sine, if it's a positive value, it will always give you an angle in the first quadrant of the graph of this grid. Okay? To get the other angle, it will be over here, and I get it by taking 180 degrees minus whatever that original angle is right here, because that angle is also this measure right there. Okay? So I'm looking for that angle right there. To get it, I take 180 degrees and I subtract this angle right here. Fair enough? Okay? It does not work exactly the same for cos, but it's very similar. If I take a cos ratio, I can get another angle by taking the negative of the cos of 180 minus that original angle. Okay? So let's take a look at it. Find out for me what the cos of 30 degrees is, please.
0.866.
0.866. Okay. So what's the supplementary angle to 30 degrees? 150. So go negative cos 150 and see if you end up with the same answer.
Yeah.
Okay?
I got it. Error.
Did you do negative cos?
Or did you do second function cos?
That is, second function is -1 cos negative.
Yeah, I don't want that.
No, like a negative sign,
Yeah.
and then cos.
Negative sign. Cos 150.
Yeah.
Got it?
Yeah.
Okay, good. Okay? And tan works the same way as sine.
Only the same as cos.
Or cos, did I say sine? Thanks. Yeah, cos. Okay, so that just takes care of the first part of it. The second part of today is doing exactly what you did in the last unit, and that's just using the sine and cos laws, and that's it. Okay, so 4.2 is proving and applying sine and cos laws for obtuse triangles. Okay, so everything we did in the first, in unit 3, was acute angles, meaning angles less than 90 degrees. We're going to do the same thing now using angles that are greater than 90 degrees. So let's look at an example. Look on page 89. We have 20, 9, and 12. Okay, I want to find angle E. So I have 3 sides. So I have to use cos law, right?
Yeah.
So I've got the cos of angle E is equal to E squared minus F squared minus D squared over minus 2FD, right? Okay, so this angle and this side always have to be across from each other when we do this. So let's do this. So E is equal to cos -1, 20 squared minus 9 squared minus 12 squared over, this will have to be in a big bracket, minus 2 times 9 times 12, big bracket. Okay, find out what E is equal to, please.
144.
Oh, you guys are on the ball. 144, right on the nose?
That's like 1,
4.
I'll use in our book.
You guys are keen. Or you
Some of
also
us
look at the
did
book.
it.
Some of us have them calculated.
Okay, so 144.114. This still works, this cos law will still work for angles greater than 90. The sine law will not. Okay, so that's what we're going to look at today. You have to do questions and find out whether it works or it does not work. But the sine law will not work for angles greater than 90 degrees. Okay, and that leads us into what tomorrow's lesson is. So that's all we have today for 4.1 and 4.2. So if you're finished your test,